Dinosaurs have attracted varying degrees of scientific and public interest since their initial description in 1824. Interest has steadily increased, however, since the late 1960s, when the dinosaur renaissance began and when the Canadian Journal of Earth Sciences started to publish. Since then, there has been a feedback system, international in scope, promoting increased scientific activity and ever-increasing public attention. This has led to ever more dinosaur discoveries internationally, increased numbers of museums and parks displaying dinosaurs, more publications, blogs, and other media on dinosaurs, and, most importantly, increased numbers of people and institutions doing research on dinosaurs. About 30 new species of dinosaurs are now being described every year, adding to the more than 1,000 species already known. Furthermore, it is now acknowledged by most biologists and paleontologists that modern birds are the direct descendants of dinosaurs and that they are classified as part of the Dinosauria. Recognizing that there are more than 11,000 species of living dinosaurs has given us a better understanding of many aspects of the biology of non-avian dinosaurs. Along with technological improvements, this has revealed new and often surprising facts about their anatomy, bones, soft tissues, and even colors, interrelationships, biomechanics, growth and variation, ecology, physiology, behavior, and extinction. In spite of the intensity of research over the last 6 decades, there is no indication that the discovery of new species and new facts about their biology is slowing down. It is quite clear that there is still a lot to be learned. Dinosaur bones and other fossils have been recognized and recovered by humans for centuries. Dong, 1997, Spalding, 1993, Sargon, 1997, Major, 2011. Although initially they may have been attributed to mythological animals, like dragons or griffons, or to animals that were supposedly still alive, but living in unknown corners of the Earth. The scientific discovery of dinosaur bones came much later, and the first finds are usually considered to be the collection between 1818 and 1821 of teeth and bones from gigantic, extinct reptiles in southern England. Megalosaurus, Buckland 1824, and Iguanodon, Mantell 1825, were the first genera of dinosaurs named, and became 2 of the 3 dinosaurs that Owen, 1842, used to erect the Dinosauria. Dinosaurs have received a lot of attention because their scientific discovery, and much of that has been within the last half of that 2-century period. There was an initial period when public and scientific interest was insatiable, but 2 world wars, political turmoil, and the Great Economic Depression of the 1930s put a damper on those interests. The period between 1930 and the late 1960s was a time when there was relatively little research being done, especially in relation to changes in concepts of what dinosaurs were. Buffeteau, 1997. But things were happening that led to a resurgence in scientific interest in dinosaurs during what ultimately became known as the Dinosaur Renaissance, Baca, 1975. For example, fieldwork in Mongolia by Soviet expeditions, 1946 to 1949, and Polish-Mongolian expeditions, 1963 to 1971, led to many exciting discoveries. Lavas, 1993. In China, C.C. Young, Yang Zhongjian, collected and named many dinosaurs during this period, Dong, 1997, and Richard C. Fox started collecting dinosaurs for the University of Alberta in Dinosaur Provincial Park. And almost certainly, books by Kolber, 1968, and Keelan Jaworowska, 1969, describing these and other expeditions had their impact on the initiation of the dinosaur renaissance. The public always maintained an interest in dinosaurs, and from 1930 to 1970, they remained among the most popular exhibits in museums worldwide, and the stars of books, cartoons, comic books, movies, and toys. Glut, 1980. The Sinclair Refining Company helped keep dinosaurs in the public eye by using a sauropod as its logo, by sponsoring the first animatronic models at the World's Fair from 1932 to 1934, and life-size models at the New York World's Fair in 1964, and by various promotions with giveaway toys, books, and brochures. Scientific interest started to recover in the late 1960s, and the dinosaur renaissance was in full swing by the early 1970s. Bakker, 1975. Desmond, 1975. Robert Bakker was in fact the focal point for creating the dinosaur renaissance, in that he changed the way we looked at things with his ability to think differently and develop new approaches, his unorthodox appearance, his enthusiasm and ability to inspire others, and his willingness to debate conventional ideas. New ideas about dinosaurs emerged, and this created even more interest by the public and expanded into new regions internationally. He was an amazing inspiration to younger paleontologists, even if they did not agree with everything he said. On certain subjects, such as warm-blooded dinosaurs, classifying birds as dinosaurs were still not being worked on by many paleontologists during the 1960s and early 1970s. Most were members of the Society of Vertebrate Paleontology, SVP, and attended the annual meetings. The dinosaur sessions were generally relatively small, both in terms of numbers of talks and attendance. However, in 1988, the annual meeting was hosted by the newly opened Tyrrell Museum of Paleontology in Drumheller. The conference is generally relatively large, and many of the meetings from around that time had attracted more than 1,000 delegates. This is a number that would have been impossible for a town the size of Drumheller, with a population of about 7,000 people, to host. But delegates were willing to suffer some inconveniences, and some stayed in hotels that were more than an hour from Drumheller. The museum itself was also pushed to the limits to run the technical sessions, as the theatre was only designed to hold 250 people. Some of the collection's storage spaces were temporarily cleaned out and set up to seat larger audiences. Previous SVP meetings had larger sessions for fossil mammals and topics other than dinosaurs, so these topics were given the larger rooms. However, everything turned around at that 1988 meeting, and more people wanted to listen to the dinosaur talks. Consequently, we needed to change the auditorium for the dinosaur session to accommodate the largest audience of the conference. And since that year, the dinosaur sessions at the SVP meetings have steadily increased in the numbers of talks and attendance. In most recent meetings, almost a third of the talks, 2 of the 6 scientific sessions, have been focused on dinosaurs. Without a doubt, paleontology has always been influenced by its parents, geology and biology. For the first century and a half, geology was the dominant parent of paleontology, as scientists focused on finding new localities, new formations, and new specimens. There is no question that 2 major developments in geology, the refinement of radiometric dating and the acceptance in the late 1960s of continental drift, probably also had a major influence on the development of the dinosaur renaissance. The description of new species, the identification of associated floras and faunas, and recognition of evolutionary trends were, of course, more biological problems, but were a consequence of finding the specimens. Feedback between the two disciplines constantly refined the search for new sites and the recovery of information from both sites and specimens. As collections became larger in public institutions, the need to go out and find new material was less important. Nowhere is this better manifested than the development of taphonomy, the study of what happens between the death of an organism and its ultimate internment in the sediments, or more simply worded as the transition of remains from the biosphere into the lithosphere. The concept was defined by the Russian scientist Efremov, 1940, who led the Mongolian paleontological expedition of the Academy of Sciences of the USSR from 1946 to 1949, Efremov, 1954, Kurochkin and Barsbold, 2000. One of the earliest taphonomic studies, Efremov, 1955, involving dinosaurs, was a locality in Mongolia that is referred to as the Dragon's Tomb, Figure 4. Here, multiple well-preserved skeletons of Saurolophus were buried en masse. Efremov, 1958, Bell et al., 2018, which amongst other things suggest that they were herding at the time of their death. The significance of taphonomic studies towards understanding the paleoecology of dinosaur-dominated faunas spread to North America. Dodson did one of the first taphonomic studies when he spent the summers of 1968 and 1969 in Dinosaur Provincial Park collecting sedimentological data from dinosaur quarries that had been marked by Sternberg, 1950. The taphonomic work was a prerequisite for undertaking a paleoecological study of the dinosaur fauna of what was called the Old Man Formation at that time. Dodson, 1971. The number of recognized dinosaurs is constantly increasing, although it should be pointed out that the number of genera and species will never be agreed on by all workers. There are many reasons for this. First, many, in fact most, taxa are based on specimens that are incomplete, and the recovery of additional material can sometimes reveal inconsistencies with the original interpretation of characters. As will be discussed later, paleontologists and other biologists can have different tendencies to be splitters, who emphasize differences to create new taxa, or lumpers, who interpret differences as variation or perhaps preservational distortion. These people tend to synonymize taxa. There are many other reasons for different paleontologists to accept different taxon counts, but over time, the taxonomic number does increase with additional discoveries and research. Benton, 2008 AB. Nevertheless, without a full understanding of genetic composition, which may never be possible for any non-avian dinosaur species, taxonomy will always be an uncertain. When the name Dinosauria was created, Owen, 1842, based it on 3 genera, Hylaeosaurus, Iguanodon, and Megalosaurus, although other genera that ultimately turned out to be dinosaurs were known at that time: Cetiosaurus, Poikilopleuron, and Streptospondylus. During the 1960s, fewer than 3 dinosaur genera were being described per annum, Olszewski, 1991, and an estimated 170 genera had been named as of 1969. Dodson, 1994. By 1989, 540 genera and about 800 species had been described. However, many of these names were based on incomplete or inadequate material, and the number of valid genera was estimated to have been only 285. Dodson, 1990. This number increased by 51 to 336 over the next 7 years. Holmes and Dodson, 1997, at an average rate of 7.3 genera per year. And then during the following 15 years, the average annual rate of description had more than doubled. Wang and Dodson, 2006, so that the total number of genera recognized as valid rose to 527. At the species level, Benton, 2008a, found that at the end of 2004, 1,401 species had been named, but only 726 of them were regarded as valid. Although there has not been a recent summary of the number of dinosaurs known at present, online estimates suggest there are now about 900 genera and more than 1,000 species, which, if true, suggests that 25 to 30 new animals are being described annually. Although the calendar year 2022 was not over when this was being written, about 30 new dinosaur genera had already been published. To most people, it sounds like we know a staggering number of dinosaurs. However, most people are also unaware that there are more than 6,000 living species of mammals, more than 10,000 living species of reptiles, and close to 11,000 extant birds, which are, as will be discussed, living dinosaurs. Considering that non-avian dinosaurs dominated the world for almost 150 million years, and that they lived in virtually every terrestrial species recovered, will never be more than a fraction of the number that must have existed.